Today we're going to talk about graphing inequalities. Before we can do that, we need to quickly review some of the basics of inequalities in graphing. Back when we learned how to graph inequality quadratics, we remember that anytime you have an equals to sign, it's a solid line, and anytime you don't have an equals to sign, you make a dotted line. Whenever you have a less than or equal to, you're going to shade below the line. Whenever you have a greater than or equal to, shade above the line. Also remember that when we're graphing lines, our equation for graphing is y equals mx plus b, where m is the slope and b is the y-intercept. You cannot graph unless your line is already in that form. Let's take a look at one example. If I asked you to graph 3x plus 2y is greater than 6. This is not in y equals mx plus b form, so the first thing that we need to do is solve for y. So we're going to subtract 3x from both sides. Bring down the 2y, so it's negative 3x plus 6. Divide both sides by 2. Now notice we're dividing by a positive 2, so we do not have to flip this inequality symbol. If this had been a negative 2, then we would have needed to change this inequality symbol to a less than. Anytime you divide by a negative, you have to flip the inequality sign. So to finish this question, y is greater than negative 3 halves x plus 3. So if we come over here to graph it, your y-intercept is positive 3, because that's what's written at the end in y equals mx plus b, so you're going to put a dot on positive 3. The slope is negative 3 halves, so I'm going to go negative in one of my directions. Remember, don't go negative in both, just go negative in one. So if I choose to go down 3, then I need to go to the right 2. Down 3 to the right 2. And if you wanted to extend it and go the other direction, you can go up 3 and to the left 2. So you've got your 4 points in a row. Now, this does not have an equals to sign, which means that we need to make this into a dotted line. Do not connect the dots with a solid line. You connect them with a dotted or dashed line like this. Now, it's a greater than question, which means we need to shade above the line. You can always check to see if you've shaded correctly by selecting a point somewhere in your shaded area and making sure that that point is actually true for this question. So if I look at my shaded area right here, I've got this point right here, 3, 3. I am going to check and make sure that this point actually makes the equation true. So I'm going to go over to my equation and I'm going to substitute 3 in for x and y. Now I'm going to get a fraction, but that's okay. I'll survive a fraction. Negative 3 halves times 3 is negative 4.5, and you can change that to a decimal if you want, plus 3. Negative 4.5 plus 3 is negative 1.5. 3 is greater than negative 1.5. This is a true statement. Therefore, I did my shading correctly. If I had gotten to the end of my problem and realized that was not a true statement, then I would have needed to check a point on the other side of my line to see if that point was true. Just to show you, if you were to select the point 0, 0, that's not in my shaded region, so it should not make my inequality true. If I come over here and I check the point 0, 0, it shouldn't give me a true statement. If I put that in, negative 3 halves times 0 is 0, so this is just a 3. 3 is not greater than 3. It's greater than or equal to, but there's no equals to sign here, so as it stands, this is not a true statement, which means 0, 0 should not have been included in my shading. Since 0, 0 is not in my shading, I know that I've done it correctly.